Okay, next video, we're going to be implementing the last of this W21 CPP code. And again, I'm going to have some to-dos. This scroll trackpad, I'm really bad at trackpads compared to mice now. Okay, so remove from back, another function I need to do. What does it do? Well, I could call the parent's version of remove from back. Okay, that sounds like a plan. And so turn is equal to linked list. If I could type, remove from back. That's implemented, that's good. And then if, what do I have in this case? No matter what, oh boy, that's the issue. No matter what, if I have a node that I've removed, the only possible case that this is going to go safely and nicely is if there was no previous, right? If I have one node and I remove it, I'm fine. If I have 0 nodes and I remove it, so I could potentially get the last and then, oh, that might work. So, but it still might work for as a to-do. Okay, so let's see here. LL node P new last, something like that, is equal to, I forget the name of it, get last. Do I have a get end? Get end. Uh-oh. But my get end is not going to work as the way I expect. My get, oh, I can call the parents version of this, but I don't think I'm going to want to do that anyways. But I'll do it for now. The reason I want to call the parents version of this is because I have this pointer that is pend. And so when I call getEnd in a W-linked list, I just jump right to it. I have it. It's right there in my hand. So the only time I need to walk down my entire linked list is if I'm doing it in a normal linked list. In a normal linked list. So as a result, what I need to do is call the parents version of this, get to the end. I could do this. I'm going to fix it because this is gonna not look so nice. Okay, if p new last. So if there's a new last element in there, if p new last does not equal null, then what do I need to do? P end is equal to p new last, and then turn to turn. Will that do? That actually might work. I don't like it. It's ugly, but it could work. Okay, so if that's not, if there is a last node, but if there was no last node, then my p end is equal to, actually, almost no matter what. Actually, no matter what, if I call the linked list nodes version of, I don't even need this check. If this get end here, if this returns null, what happens? If I then I would set p end to null. Wait, that's exactly what I want to do in this case. So I actually don't need this if statement. That's really quite nice. That's elegant. I will want to change some stuff around. So I could do this. So I can call the parents version of getEnd, walks all the way down my linked list. I'm going to change that because that's actually slow. I have to walk all the way down my linked list. If I have 4,000 elements, I got to walk down 4,000 elements. I might want to just go one step back, which is a nicer way, but I have it as a to-do, at least for right now. Okay, let me finish off the rest of this. Okay, getEnd. Here is the reason why if I can move my mouse pointer, here is the reason why I used a W-linked list. Done. Set end pointer. Oh, p end is equal to p new end. Done. Okay. All the other functions, just to point these things out right away. every other function that we have in here, if I didn't re-implement it, if I didn't, override the old way of doing it, it's still there. I get it for free. I don't have to copy and paste all my code for this new class from the old class. I take just the parts that I need to change, or I take all the parts, and I just change the little parts that I need to change. That's why I use inheritance. It saves me from repeating myself or repeating code, which is ironic given the number of times I've had to redo this video, that I have to redo the video a bunch of times when I'm not redoing code. Okay, let's have a look at what this thing actually does. Hopefully it's going to work. If it doesn't, well, we're going to find out. Okay, so I added a whole bunch of nodes, added 5. I'm going to remove 2. I get these 2. I get 3 nodes. I'm going to remove 2 more. I get 1 node. I remove another 2. I get an empty linked list. I changed the code yesterday without you guys knowing. Well, if you watch the videos that doesn't exist anymore, you would know this. And I added 2 new nodes to it. I'm adding it at the front, and I'm adding it at the back. So I added the 0 at the back, and then I added the 1, the negative 2 at the front. Here it is. I then remove 1 node from the front. There it is. And then I delete the whole thing. Okay. I'm going to stop there, well, the video there, and we're going to do another example. The next example is, well, we're claiming we have a double linked list, but all I have is a linked list that I also point to the end. That's all I've done that's new. A doubly linked list gives us a bit of extra power from that. We get a previous, and that can do some interesting things. It's especially powerful later on if you're trying to search through this thing, or you're trying to get the very last element, or whatever the case is, where you don't want to just walk down the entire linked list each time. So I'm going to pause it there. We're going to start a new video, and you're going to see a brand new class called DLL node and how that's going to be implemented. All right, thanks.